Welcome to the TWIML AI podcast. I'm your host, Sam Charrington.
Hey everyone, producer Umare here. As we mentioned on the podcast last week, we've got some exciting new additions to our TWIML community programs, including the IBM AI Enterprise Workflow Specialization Study Group, which will be hosted by Sam, and the Causal Modeling in Machine Learning Study Group, hosted by Robert Osazuwa-Ness, who you heard from earlier this week on the topic of causality. Today, I want to remind you that Sam and Robert are hosting a course and study group overview session this Saturday, February 1st at 8 a.m. Pacific Time. To get signed up for this course, or to learn more about the other upcoming and ongoing TWIML community programs, visit twimlai.com/community. And now, on to the show.
All right, everyone. I am here with Haytham AbuelFutuh and Ketan Umare from Lyft. Haytham and Ketan, welcome to the TWIML AI podcast.
Thank you.
Thank you.
So we're here in, once again, sunny San Diego. We got the 2 days of horrible, miserable, rainy weather, earlier in this week. And we're here to talk about some of what you're doing in Lyft, namely the Flyte project that you just presented on yesterday.
It's open sourced.
And it's open sourced.
Yep,
and it's open source. So we're going to dig deep into this. But before we do, I'd love to have each of you kind of introduce yourselves, share a little bit about your background, how you got to work on ML infra, and, what's your story? Talk to us. Ketan?
Yeah. Hey, my name is Ketan. I lead the Flyte team and probably one of the founding person of Flyte at Lyft. So my background is I work across different industries, from hedge funds to retail to logistics to cloud and mapping, and now finally back in sort of transportation area. And one of the things I've been interested in is just large scale data processing and solving business problems where data and computation comes together, and machine learning is a place where that's really, really important. I started Lyft in 2016, but I started on Flyte close to the end of 2016. And it was mostly I started working on this team. We were trying to get ETAs, which are I'll explain what an ETA is. So when you open up a Lyft app and you see, hey, 3 minutes to get your driver, or if you are in your car and you see it will take 15 minutes to reach the airport, sometimes it's accurate. And it's accurate mostly because of a ton of machine learning models that go in the background, and including understanding how the road traffic is and understanding all kinds of things that are happening in the current conditions on the road. So so I was leading that team, and I joined the team. There was another engineer on it. He used to run the models all on his laptop. And we were like, how are you running this? And he's like, I have this script. I've just run this, and it just runs and it figures out. And then I run this other script, and then I run this other script. And I do, that's crazy. So I'm
trying to decide whether to interrupt you and just dive deep into that. That sounds crazy.
It is crazy.
Running a model that's doing live prediction of ETAs on
it's
the
not
laptop,
live,
or
no.
training?
This is training the model.
Okay,
this is training the model,
Okay.
or collecting the data for the model, or things like that, right? And actually,
still, there are reproducibility issues and stuff like that.
A lot of issues.
Yeah.
But you wouldn't be surprised how many times this happens in the industry, right? It's just and this is actually how we'll lead into it, because this is the current state of the infrastructure for machine learning, and especially productionizing models didn't exist. We didn't think about retraining these models at that time, and quickly we wanted to retrain them, and then the laptop's not going to scale. The other story that happened, so this is just leading into Flyte, right? And the other story that happened is there was a research scientist on my team. He created a model, and that model is pretty cool. It served Lyft for many years, but he left the company, and the model went with him, probably. So we lost it. We had no idea where the model was. And as a leader, they told me, hey, let's recreate this model. And I don't know how to. And I we knew the algorithm, so we just rewrote it and got everything done. It would not give the same results, and it literally took us 3 months to get like to the same level of accuracy.
Wow.
And we were like, okay, so he had done all of this extra work that we really kind of lost. We didn't waste too much effort on it because we knew the algorithm and we knew some of the tricks, but still it's like wasted effort in trying something out and then going and trying out the accuracy, and you're like, oh, it's
3
not
months
the same.
You could have spent on something else.
Yeah, it's not like one person spending all the 3 months, but it's still like it's wasted effort. So at that time, I decided that this needs to change, and delivering new models became slower and slower. So that was the birth of Flyte. At that point, we used to call it a bad name. I'm not even going to put it on the on the podcast, but I used to, and I wrote like a first draft proposal internally, and everybody was like, "You're crazy. This thing is never going to work." But somehow, in like a couple months, we erected like the V0, V1 of this thing, and we got a team to try it out, and this team was also struggling a lot with delivering their models. And the intersection where Flyte really fits in is when you have a lot of data and you want to reproduce your models again and again, like maybe every day, every week, or every hour, and you want like the trace of what happened and the lineage between everything. And this team actually fit the bill. And they, for the first time, they were able to deliver a model in like 6 months, and this was a gigantic model. It affected the bottom line of Lyft, and it was really, really meaningful. And it was not without a lot of stress and working hard through the nights. But that was the starting of Flyte, and that was in 2017. And then we didn't stop. Like the use in the company just skyrocketed. And we, at that point, we were like, hey, we should open source this thing because it's such a big problem to solve that a small team at Lyft can probably never solve it on their own. And if you open source it, we should be able to work with the community, hear more ideas, and improve it all the time. So we actually rewrote everything from scratch, made it Kubernetes native, took like the primitives that we understood from looking at all the various use cases. And that's the amazing part of Lyft. Like, it's a rich ground of amazing use cases. And we used all of that and basically distill that information into Flyte. And that's our first cut into the world.
Haytham, tell us about your background and what you do at Lyft.
Sure. Yes. So my name is Haytham AbuelFutuh. I have worked previously at Microsoft and Google, and I had a journey, up and down the stack. I worked in like enterprise grade applications in low level storage, like Azure storage, and I, at some point wanted to try out ML, and I kind of found this sweet spot in ML infra to fit the bill kind of thing for me. I joined Lyft 2 years ago, January. And at that time, it was that we're still stabilizing the prior incarnation of Flyte, the unnamed product. It was great and teams loved it. But as Ketan was saying, at that point, I joined in the midst of this discussion about what do we do next. So I got to be part of the decision about going Kubernetes native and all the very I see as critical design decisions we took in Flyte to architectural decisions, all the going with a very strong type system and very strong language specifications through protobuf. Like there are a lot of things we view, we are like very opinionated about in Flyte, and a lot of things we are not. We explicitly decided to leave open. We, based on the experience we had, we think we found a good path for where we give you the learnings, or enforce the learnings we have had before in how we ask you to write your code or deliver your models or your data processing tasks or whatever, and at the same time leave it open for a variety of different workloads that can run on the system. And there we are. I'm very proud with how the product turned out to be, and the launch and the reception we have had during the conference.
Awesome. And just a shout out to the team. It wouldn't have been possible without just crazy amounts of effort with the team. It's an amazing team at Lyft.
Yes.
And we are proud of all our users also at Lyft. Just they have like stayed with us through bad times and good times, and thank you for all the support.
That's awesome. Awesome. So, Ketan, you've given us kind of a little bit of an overview of Flyte. Maybe take a step back and what's the core value proposition that Flyte is offering? And Haytham, you mentioned that it's Kubernetes native. Like, how does it relate to Cubeflow?
Yeah,
for example.
That's a good question. Let me start with the motivation of or what is it that we think is missing and what we were trying to address. One of the things, as I said, we started in 2017. So that's the landscape was very different at that point, right? So we've evolved from that point. And this is a V2, even though actually I think this is the real V1, but this is a V2. So that means we went through a process of actually making something and failing and then redoing it. That has a lot of learnings with it. So one of the learnings is that we feel that there is this artificial divide that's happening between ML and data, but actually they go hand in hand. It's not that these companies have amazing data systems. They are not the Googles, Facebooks, or the Amazons of the world, right? They are smaller companies, nimble, and they are basically building their data stack too. And the other thing that we realize is there are teams cross-collaborate quite a bit. Machine learning models are built, let's say, by a team, but the team B probably provides the data that builds that machine learning model. And actually, the fallacy of separating them is that many times in production we use machine learning models to predict, and that creates data that becomes a fact in the fact tables in the data world. And then many times you use machine learning models to convert that fact to a dimension, which trains other models. So there is this cyclic nature that's happening. And this needs to be captured at that granularity, saying that, there is data and processing and machine learning all interacting together. So that was the motivation behind Flyte, that we need a single tool and a platform that allows for collaborating, sharing, and MLOps, along with with definite focus on orchestration, and that's why at the core of Flyte is a workflow engine that actually runs all of these pipelines. But from the idea point of view, it was built for collaboration and sharing across the company, various aspects, as well as processing and machine learning on the same tool.
And so maybe to make that more concrete, we can kind of compare contrast to what Kubeflow is trying to do.
Right.
Sure.
Are they, orthogonal? Are they complementary? Does Flyte use Kubeflow?
That's a great question. So Kubeflow, it started a while ago. It started as one thing. Initially, they had just the TensorFlow operator. And as the product started maturing, it became not just a product, right? It became a collection of products under the name Kubeflow. There's Kubeflow serving, Kubeflow pipelines. TensorFlow became its own thing. You can use it on its own, and so on and so forth, right? So we don't see the comparison between Flyte and Kubeflow as a collection of tools or products. The fairer comparison, I would say, is between Flyte and Kubeflow pipelines, which is one segment of Kubeflow that sits on its own in a way. And the underlying engine, the workflow engine under Kubeflow pipelines is not actually written by Google. It's an open source product, a different product, right? So it's also swappable that way. So it's you can think of it as a puzzle kind of thing, and these are just a few pieces of that puzzle. And Flyte does things slightly differently for those few pieces that are comparable, if that makes sense.
So then, are you saying then that Flyte might be a swappable alternative to Argo under Kubeflow pipelines?
Actually, yeah, it might be more vertical than that. But I'll give you an example.
Okay.
In Kubeflow, there is PyTorch and TensorFlow.
Yeah.
two absolutely opinionated deep learning frameworks.
Yep.
They both exist, right?
Right.
And it should be the user's choice of what they want to use. And that's how I feel about how Flyte and, let's say, Kubeflow pipelines work. They could interrelate, and that absolutely, it's in our best interest to make all of these tools play very well with each other. But they could be like completely vertically available as two alternatives. And you could use Kubeflow serving to serve your models, but build those models on Flyte. This Flyte offers a great abstraction on compute, and it gives you big data with it, right? So that's essentially our differentiator, where we think like Kubeflow pipelines doesn't even try to do that. And then the lineage and the cataloging that we do is further on, built on top of it, which is also the other bit that we should talk about, I guess, later on.
Cool. You mentioned that one of the aspects of Flyte is that it's strongly typed. Makes me think most immediately to like FB Learner and kind of its approach to typing, and you're nodding your heads maybe.
Yeah.
Can you talk a little bit about that kind of design decision and its implications?
I can actually tell you the first time I saw the FB Learner blog. It's uncanny, but it's also unbelievable at some level. So we looked at it, and I shared it with the team. I'm like, did you see this? Like, this looks exactly like our, and this was around the same, I remember 2017, 2016, somewhere around that time. And we had the same, like the annotation, decorators in Python. And like, and we're like, wow, is it like, there are people thinking about like us. But actually that helped us to, just, they were earlier than us. I'm not saying that, but none of that, right? But it's just that kind of helped us believe like more in that we were probably on the right path, right? And so so we in the version 1 of Flyte, we did not have we had a type system, but the type system only existed on the SDK, as we call it, in the Python where you author the pipelines.
Maybe take a step back for folks that hear type system or strongly typed, and there's no context for that. What does that mean from the perspective of the user experience for Flyte?
Yeah. So let's say you write a function in any language. You have some inputs and outputs to that function. There are languages like Python where you do specify inputs and outputs, but you don't know what those types are, barring the new typing system.
Whether they're strings or integers or floats or whatever,
but you don't know,
or more complex things.
Could be duck typing in there and so on. But if you go to a language like Go or Java or C++, they're really strongly typed. You have to say this is an int and this is a string and that's the order and whatever, right? There are benefits of having types in the system, and that's why people love them to use them in programming languages, because you get compile time safety. When you build the function, if you pass in an int and try to use it like a string, you get an error at compile time. So you don't have to wait for it to run for 10 days and then figure out, oh shit, it failed. But in Python, actually, there's more of a movement to add these kind of typing, compile time type safety. We think that is the same thing that should be done for. Why not do it for all functions? Like in our RPC systems today, like services, microservices that people are using, we have types and we have APIs and people talk to them and then they receive outputs. In Flyte, that's how we've designed that every single function is a task, we call them, and these have inputs and outputs. And by strong typing, I mean these inputs and outputs have a known set of types. But what are the known set of types that you need to use with machine learning? So we had to come up with a type system that allows you to specify the various types of types that users use when they are building models. Like an example could be a structured schema, which is like a row vector, or could be a tensor, could be a blob, which could be a serialized model. And it could be in various formats. Could be Onyx, could be, and those could be annotations on top of that blob saying that this is a serialized with the TensorFlow serialization format. So that's the type system that we are referring to. So when you declare a task, if it's a model building task and you use joblib to serialize it, you can output a model that says it is joblib.dat. And then the next task that actually consumes it knows that, oh, this is of type joblib, so I can just load it into using joblib. And if you try to now put these two tasks together, they will work. But if you try to put a task that does not understand joblib, only uses TensorFlow, it will fail at compile time.
Right.
And that's what we wanted to achieve. In a pipeline, try to fail earlier if possible.
And then one of the things that enables for the FB Learner case is that they can take all of these tasks that are strongly typed, kind of create a dependency graph, and then execute them in parallel, like as one completes, spin off its descendants. Are you doing similar things?
Yep, exactly. I remember something I wanted to add to the typing system. So one of the things one of the decisions we made there was using protobuf to specify the types, and then that might be one of the distinctions between the existing systems you might see, even like FB Learner and others, and Flyte. And that makes it takes it one step further. It doesn't only allow you to put Python tasks together, because after you declare the task in whatever language you choose to, using our spec, you can, let's say write Go function becomes one step in your graph. The next step might be a Python task in a different container, or what have you, because at the end of the day they all compile to this standard spec that has standard set of types that are compatible with our SDK in any language. And yes, I guess back to your question, it does allow us to once you declare the graph in this spec, we have a compiler that looks at the graph and figures out the dependency graph, and we can go as parallel as the system would want, pairing the dependencies and all of that into account.
Yeah, and there are other advantages, like what I think Haytham did. I just wanted to add one more thing. Is the reason why we did this is because we saw use cases within Lyft where users were writing models in Scala for Spark processing, right? Like they just want to do Spark processing Scala. Yeah. They don't want to write this in PySpark. They do sometimes, but sometimes they want to use Scala for higher performance. And we were like, how do we move the data between these two different languages? And so that's why we came up with. So we are also using Arrow underneath. This is an open source project, but like we wanted to create a layer on top of it so that it's easy to construct these polyglot pipelines, if I may.
So we're talking about stuff like type systems and protobufs and Arrow, and not language that the typical data scientist talks about a lot.
It is.
Correct.
Is it, have you built abstractions that make it more acceptable to data scientists, or do you just have a different audience?
That's a very good question. And actually, sometimes we do debate amongst ourselves, what's our audience, right? Yeah. But we do want to appeal, in the beginning at least, to the savvy engineer like us who wants to get his hands a little dirty. But as we are progressing, we are creating layers on top of them. So think about this: we built the foundation, and now building layers on top is much easier. So, for example, we are just about to merge full notebook support, so you can write tasks in Notebook. So we're just going to add support for Jupyter notebooks. The way we are thinking about Jupyter notebooks is users like data scientists and researchers love to use Jupyter notebooks. They write code in Jupyter notebooks in a very different way than how engineers write code on using IDEs, right? So it's very different, and we want to keep and preserve that semantic of writing code. So we actually found a project called Papermill, which is pretty cool. We like that. Oh, that's pretty cool.
Originally out of Netflix. Now backed by an independent company.
Yes, and so we decided to adopt it, and we take that and we convert a notebook into a function. Into our system with the same inputs and outputs. We do the magic of passing the inputs and outputs. You just write your code as if you're writing a regular notebook. You can try it out, do whatever, drop it into a container, give it to Flyte, and then it'll take care and execute it and actually record the output notebook and store it for you. So you can go back in time and look at it even if you want to. So yes, our audience was engineers in the beginning because we do have that sort of audience at Lyft, but we also have data scientists and research scientists using more and more, and we are improving every day for them. So if you start today, you might look at the Python Flyte kit and see that it's a little more suited for people who write with IDEs. Yeah. But with the notebook introduction and in our demo, we showed like how to use everything with the notebook. We are going more towards research scientists. And they will not even see some of the things that we do. Like, for example, I'll give you an example. In a task, you can return a data frame, a pandas data frame. And we understand that a pandas data frame is actually the row vector that we do underneath, which is converted to a protobuf and arrow, and it's just sent through. You don't even have to think about it. You just work with pandas data frame. And hopefully, we are thinking, we're not yet implemented this, but that goes into Spark data frame and the other side. Okay. So we created the abstraction layer for that.
Okay. Does that introduce a lot of latency? I was having a conversation with someone who was talking about reason why they don't use TF serving is because they're primarily doing inferencing on images, and it requires that you have to put everything into a data frame, and there's a bunch of latency that introduces. Do you run into these kinds of issues where your abstraction, hides kind of some nimbleness in what the underlying data format is, and you're doing conversions underneath the covers?
So actually, Arrow in that case is an extremely interesting project, according to me. The aim is to make zero copy abstractions from one format to pandas data frame to Spark data frames. And I think the founder it's Wes, the guy who made pandas. Yeah. Yep. So I have been following that project, and I think that's like more of that is required, where we just should stop wasting CPU cycles on transforming data from one format or one language to another, and more use the zero copy abstractions that we can create. And that just makes the open source ecosystem much nicer. And that's why we chose Arrow. But you don't have to, like, for example, if you're emitting out images, you don't have to have a data frame for it in Flyte. You can just say, I am emitting a directory of million images, and we will take the million images and upload them and download them onto the other machines and use them. Okay. So there is, like, you can use data frames, but you don't have to. And that's where the type system comes in. Okay. It needs to be more granular then.
Okay. So we've talked a bunch about the type system and the workflow that enables, and kind of some of the user experience. In introducing Flyte, you mentioned this important idea of kind of connecting back to the data and enabling things like end-to-end data provenance, and this kind of loop that you pointed out where your inference actually is data for your next train or a future train at least. Talk more about kind of how that works. Like, I'm thinking the thing that comes to mind as I'm hearing that is Airbnb has a project that's kind of an adjacent project to their Big Head platform that is focused on like doing, point in time feature mapping and management and feature repository, that kind of thing. Is that the kind of thing we're talking about?
That could be one of the things, but it's not like exactly what we're talking about. But like, I think it's feature service is, let's call it like a generic name.
Feature service.
Features as a service, right? Would is an implementation on top of this potentially that allows you to pass data, like consume the data back into the model, and also build and send it to feature service. What we are referring to is the causal dependencies between the compute and the actual production of that data, and then further consumption of data by the next compute layer and production. So now let's take an example. You get a map from OSM, OpenStreetMaps, if we consume it, and you build a graph, the road network out of it. Then some other team actually analyzes the road network in real time that's happening and creates the traffic pattern that are happening at the moment on the road, and annotates the road network with some speed profiles. That's what we call them. And then the third team actually consumes these two things and creates the final road network that's deployed to production. So when we did a prediction on ETA, we would want to know, hey, which version of the map did I use? And what was the speed profile at that point in time? And what were the traffic conditions that led to that speed profile? That's the type of question that we want to answer. So to go to that, you need to have a full trace in the system of how the data was generated, when did it get generated, when did it get passed on to the next bit. And then, so we call this typically lineage or provenance, as you said. And the way we track this is our type system was the other reason why we had our type system is to have the central engine automatically publish all of this data as it's generated by every single task execution to a central service that actually just records a unique signature of the execution and what did it generate with the inputs and the outputs. So now you have a relationship between what got generated by what. And now you can create a graph because you know the graph that ran. Like Flyte knows intrinsically that what was the computation graph. So you can go in and create the causal dependency structure across these data sets. We do this today. The exposed thing that you get in open source is not the full. We don't show the dependency tree that will come out soon at some point, but we are using this for memorization. So if you recompute the same data set, let's say you took some data set and you transformed it and it produced an output. Some other user goes in and takes the same data set and transforms it and produces the same output potentially because the code really has not changed. In the past, people would we would spend money
on wasting a lot of compute.
A lot of compute. And
inventing the wheel.
Doing the same thing. Yeah. So then the solution would be, let's create a intermediate Hive table or whatever, right? Things like that. But that's not really what it was for many artifacts that are like images, right? They're not. If you did luminance sampling on some set of images, you're not going to store them in Hive. I think people do that, but we don't. But what we do is because we can identify the compute process and the set of inputs that were given, we create a unique signature of that. And so next time when we observe that the same thing is being run, Flyte just smartly replaces it with the existing outputs. Now you have to tell Flyte that this process is reproducible. Because if it has side effects or it is like, if you're using random number to generate or something, that might not work. So you have to tell us. But if you tell us, then we just go and replace any execution of that on the platform across the company. So that saves money and time. Because the iteration time now, like if you're running something that's 10 steps, like a 10-step pipeline, and you fail on the 10th step, you just fix the 10th step and rerun it.
Right.
And the 9 steps just are cached. So you just automatically Flyte will fast forward you to the 10th step and say, okay, let's run that guy again. And so this is what we call as memorization.
So Flyte isn't, you've described it as kind of a workflow engine. It's not a data store or something that is like creating snapshots or anything. It's more like, you can think of it more like metadata and pointers to existing training data and interim data, transform data, output data, et cetera.
Exactly.
Yep.
Exactly.
And or presumably you're also kind of tracking model versions as they're trained.
Yes. So we have. That's one of the things we are a bit opinionated about. Flyte is every artifact in the system, all the data produced, all the definitions of all the tasks and workflows are immutable. So we have strict versioning scheme. That you can use your own versioning scheme, but it has to be strict, as in you can't mutate something and try to register it or produce it with the same version again. So when we produce any metadata about tasks, outputs, or whatnot, they're always unique, or the signature is always unique, and that allows us throughout the system to always refer to very consistently to past executions in the history and the produced artifacts and produced models and anything that went through the system with very confidence that we know exactly which even piece of code produced that.
And you should be able to fully reproduce it, but it'll cause a new version. We don't even have one single update API in the entire code base. So
because you have
it's like a functional
that system. Yes.
What's the smallest kind of use case that you can envision someone using this for? Does it make sense, and is it kind of approachable enough for kind of a single person to kind of clone a repo and like actually get some value out of it, or do you need a team of 10 ML infra people?
That's a great
question. Great question. Yes, and I will say like our work there is not done, but we have put a lot of effort to make the first time experience and the maintenance for small projects, as you mentioned, very approachable. We have written docs that, like, I would say maybe most of the time, like the effort we put in the docs were in the docs that tell people how to get started. So it's like made that easy. We even sometimes went back to like our architecture and whatnot to try to make that easy. When like we looked at the docs and it's like, that's a lot of steps. This is not okay. Let's go back and redo things, right? So that's one part of it. I would say the other part I think is we have seen that in a lot of cases. People, when they get started in developing a model or even doing some transformation or whatnot, they don't think initially, unless they have done that before, they don't think that they will need a workflow for it. They think, we'll spawn off a notebook and do my thing and I'll be happy, right? Which usually is the case in the beginning, right? Until, somebody leaves the company or you want to go back to a model that worked, but you don't know which version of the code produced that and so on. And then you start realizing the problems and the need for such systems. But by trying to make it as easy to get started, as approachable, we hope that at one point it becomes like a standard or a given that you always start there. And the system, like the friction between I have nothing to the first task or the first execution is almost not there. More people would get into the habit of doing this as the first step before writing your first piece of code, and it sets you up for success later.
We are basically saying that every company should grow and become great, and start with what we think is like the bare minimum, and it will evolve with you, right? So it's an evolvable system. The other bit that I want to add to that is that I think that one of the reasons why we moved to Kubernetes is to make that like that first case experience and like for small company experience really, really good. Kubernetes is great to get, like, you can go to any of the clouds and get one Kubernetes cluster. And we use Kustomize. I don't know if you know of that project, but that's like a pretty interesting project. All of Flyte is really one YAML. And you can say kubectl apply -f that YAML, and boom, you get a Flyte cluster, including all the things that we just talked about.
Wow. Okay.
Yeah, you can even do that on the like a Docker for desktop or equivalent. Like on your machine, you don't even have to go to a cloud provider to get started. And it will set it up even with menu for storage. So you'll get like the full experience. You run your tasks, and once you're ready to take it to the next level, run on AWS or GCP or whatnot, you don't have to like change how you were doing things or how you wrote your tasks. They will just seamlessly run on a bigger cloud. Within Lyft, and we talked about this in the presentation yesterday, we run a multi-cluster setup Flyte. It's not a single cluster, but of course, you will not start there, right? And we did not start there. We started with a single cluster. We soon outgrew that and started, deploying multiple clusters of Flyte. And the users.
When you say multi-cluster, what's the multi-tenancy models? Like a single user has stuff running on multi-clusters, or you just have multi-clusters and you have some users on one cluster and some on another?
We have multiple clusters, and for the user though, it's one cluster. So we abstract that entire thing behind a service. And the way we spawn off the work, it depends on the load of the system or priority classes or things like that.
And is that all stuff that's happening in the open source, or this is all related to the way that you're operating it?
No, it's all open source.
Interesting.
You don't need to do this. Like you don't have to use multi-cluster, but let's say your company grows further beyond that single cluster. Yes, Flyte will evolve with you. We basically open source everything that we do at Lyft. Some other things that I just talked about, like the lineage and whatever, will come soon. But most of the things.
What's exciting about this for me is that, there are many, many companies that are doing this kind of thing internally. we talked about Facebook, Airbnb, Uber, obviously with Michelangelo. Some have talked about open sourcing,
sure.
But I'm not sure I can think of, any kind of name brand company that has open sourced their internal platform, outside of like TFX, if you consider that Google open sourcing their internal platform.
Yeah.
So this is...
TFX doesn't come with an execution portion of it, right? It's just basically the library at the moment.
Right. And so this is the library that does all the type stuff. There's the execution piece, workflow engine. After the step after the kubectl, like, is it spinning up a web front end that I can see stuff?
Our web front end's pretty snappy too. We show like errors in the UI and graphs and things like that. You can click, you get log links in the UI and like inputs and outputs and the artifacts produced. All of that is in the UI too.
Yep.
That's
and
awesome.
there's the CLI too, of course.
Tell me a little bit about the process of open sourcing it. Like, was that... the size says it all.
So my life has been like, so I had a baby 5 months ago, and I had another baby now, Flyte. So it's like literally having two babies at the same time. It's a twins, and I've not slept almost for 5 months probably, and so has the team. Like, been a fantastic job. So. Yeah, that's why we took this long, actually. We started the process last year. We could have been...
let's start with why.
Very good question. Yeah, like, why?
And we did debate that a lot internally, right? Like, because especially the previous system wasn't going to be open source. It was Lyft only. So like when this came, when we decided to rebuild it.
I remember even Haytham joined, and that was one of the questions. Why do you want to open source it, right? Like, I think what happened is there was interest from outside was one of the reasons. I don't need to name like where it was, but there was some interest. The other thing is we realized this is such a big problem to solve that, and I said this I think before, but a small 9 or 10 people team cannot do this, right? It needs to be an industry-wide effort, hopefully. If not, at least like a few tens of people working on this, and all with like, if we do set the right primitives, then we can let it evolve into the piece that it needs to be, right? And that gets great stuff for Lyft. Like if we get, for example, we currently only have a Python SDK, but I know there are other companies that are saying that we want to add a Scala SDK for this, and we are like, awesome, we will use it, right? Because there is demand for this at Lyft. But we don't have the time to build this. So that's a definite biggest reason that get basic leverage. Second is Lyft open sourced Envoy. It was a foundational technology for Lyft too, and it's been amazing success, right?
Kubernetes community.
So
we are not saying we are going to be even 10% of that. That's just too much. But from that we learned that people actually it's a great hiring tool. You are not working on a technology in the company that now you have to hire engineers and teach them. You are going to work on a technology that they have probably used at their previous jobs, and that's great for Lyft. So, and so just great for the team potentially, right? So why not?
And I would like to just add to all of this. I think as we talked throughout the conversation today, there are a few things we strongly believe in. And we wanted to have that debate in the open because I think it will not only influence like this product or similar products, it will influence like the entire ecosystem, how it interacts with each other, how you do serving even after like all of that, even if you don't build these pieces, the concepts, like the underlying concepts, and I think we see that it does bring something to the table that isn't there yet. So we wanted to make sure that, we have that conversation. Like it will, we think, advance like the entire, like the ML infra community overall to hopefully a slightly better place.
Well, Haytham, Ketan, thanks so much for taking the time to chat with us.
Thank you, Sam.
Thanks for having us.
Yeah.
All right, everyone, that's our show for today. To learn more about today's guest or the topics mentioned in the interview, visit twimlai.com/shows. For more information on either of our new study group offerings, causal modeling and machine learning, or the IBM Enterprise AI workflow, visit twimlai.com/learn2020. Of course, if you like what you hear on the podcast, be sure to subscribe, rate, and review the show on your favorite podcatcher. Thanks so much for listening, and catch you next time.